Good evening, guys. So we're going to go over question 7 real quick. This is just to give you a start so you can figure. So, question 7. It says, an inductor is connected to a 240 volt, 1000 hertz line. The circuit current is 0.6 amps. What is the inductance of the inductor? Now, it sounds intimidating because there's a lot of stuff coming your way. So let's make this simple. First, we have voltage. What is voltage when we're calculating this stuff? It's equal to E. So we have E equals voltage. So E equals voltage, Hz, which is our hertz, equals F. Man, my pencil does not want to draw tonight. And then we have amps. They've given us amps. Wow, my pencil does not like me tonight, which is equal to I when we're dealing with formulas. So we have F in our formulas. We have E in our formulas. So what formulas use E and I? Well, there's the formula for X sub L equals E over I. Well, we have two of those three, which means we can get additional information. So our hertz is, let's see, 240 volts. Let's start there. So we have 240 volts, which is E. We have 1000 hertz. And I have no idea if I'm pronouncing that right, and I really don't care. It's one of those things. 0.6 amps. So now X sub L equals, E is voltage, so it's 240 over I, which is 0.6. All right. So what happens when you divide 240 by 0.6? Well, you end up with X sub L equaling 400. Now, so this brings up the question, okay, well, what does that do for us? And for some reason tonight, it is registering my hand with everything. Last time I did a recording, it didn't do that. So it looks like our paper's all dirty. So anyways, we now have X sub L. So there's another formula that we can now use here. And that is L equals X sub L over 2 times pi times F. Well, we have X sub L and we have F, and we know what pi is. So it's L equals our 400, because that's what our X sub L is now. X sub L is equal to 400. And I should have put X sub L there. 2 times pi, which if you still have that from the other, which I have it in my notes, it is 6.2832. That's 2 times pi. And it is that, our F in this formula, because our formula is X sub L over 2 times pi times F. And we have an F, which is our hertz, which is the 1000. So this is that times 1 times 1000. And now we come out with that. It becomes 400 divided by this, and your total ultimately comes out to 0.06366. I'll be honest, I do not know what is going on with my laptop tonight. It is determined to be a mess. I think something is interfering. It's like it's supposed to go straight to drawing mode and not use anything other than the pencil, but for some reason it's taking input from my hand that's laying on the screen. So anyways, but you have that is now your L. So go find out what your L is. That's as far as I'm getting you for right now, because in question 7, what is the inductance of the inductor? Well, what does L equal? L equals your inductance, or H. So look right there. You have your answer. You have L, which is your inductance. You're done. So for a lot of these problems, it will give you a certain amount of information. This is why it's important to grab the formulas from the book for this chapter and lay them out. And then when you come to these practice problems, just go, okay, well, I've got 1, 2, 3, whatever, how many pieces of information, how many of them plug into formulas here. And if you've just got a sheet of paper next to you with a whole bunch of formulas on it, you can go, okay, here's a formula. This has 3 unknowns and I have 2 of the unknowns. So you now have 1 unknown so you can solve. Remember, you can only solve if there's 1 unknown, so it'll give you the right information. And these are not questions that you cannot get an answer to. These are all supposed to be solved. So just look at your formulas, go, okay, this is what I have here, this is what I have here. Find the right formula, just search through them, and it makes it a lot easier because otherwise you're flipping through the book going, okay, where's the formula, where's the formula? And one of the easiest ways to search for the correct formula is if you figure out what it's asking for, so inductance. So inductance is L. So you can go, okay, I need L. And then you can search through your formulas. So right here, L is on page 429. There's a formula for L. L equals X sub L over 2 times pi times F. And, oh, okay, that's how you get L. So you can go, okay, well, like my Hertz is F, so I just need my X sub L in order to use this formula. Okay, so how do we calculate X sub L? What are the different ways we can do that? So you go looking for another formula, and again, if you have them all written down, you don't have to go looking in another place. And so that is why your first formula of X sub L equals E over I, you can just go, okay, what equals X sub L? And you can look at your formulas and go, okay, here's one for this. Here's the information I need. Now, sometimes there are multiple formulas. So there are formulas for X sub L, that is the square root of Z squared minus R squared. So it depends on what information. Like you probably aren't going to have that because that requires resistance and Z is for something else. I don't remember off the top of my head, but you may not have that information. So you keep going. Or if you have something else, you find, oh, okay, I have R, which is resistance. So I have R and I have this other one, and oh, that's Z. So now I know that this is the formula I want to use. It's X sub L equals the square root of Z squared minus R squared. And that's how you find your formula. So rather than get overwhelmed by these questions, once you just take it and go, okay, what information do I have? What formula will that let me use? Because this isn't a trick question. There's going to be a formula for it. And it will make your life much easier if you will lay out those formulas and then make sure you get the letters connected to what they are. So E is voltage, Hz or Hertz is F, I equals amps, current equals amps, or I. So they will use these different words, but if you've already got it laid out, you can go, okay, well, current is amps equals I, and it asks for current. You go, oh, okay, then I just need to find current. So that means I'm looking for I. Just keep it all together because we'll be using all this same stuff for the next 2 days yet. It builds upon this, and So if you've got all this stuff set aside already, it will be a lot easier the next 2 days. So just take a little extra time, build your notes, put them together, and go from there. So anyways, guys, if you need any help, don't hesitate to call, to text, or we will be doing live questions. So get on Google Teams and ask us questions. We can work through this. I can work live on this. Just how I did this problem, we can work through problems that way as well, so you can see how this is going. You can listen to other students who will be on there, because some of them will have memorized this already, and you know. So go ahead and get started on this. If you've got any questions, we will be online for quite a while. And even if we aren't online, let us know. Text us, call us, just let us know if you need help. All right, guys, good night.